Hi, Ankita. Let me introduce Neelima to you. Neelima, please introduce our speaker.
Yeah, sure. So welcome everyone from this is another webinar session from Kerala Blockchain Academy. So we have this session on exploring decentralization and digital identity credentials, and we are so excited to have with us Ms. Ankita Patidar from Ironworks. She's a tech lead at Ironworks, and she has over 5 years of experience in blockchain technologies and expertise in working with blockchains, including Hyperledger and Corda. Over to you, Ankita.
Yes, thank you so much for the introduction, Nilima. So, myself, Ankita Patidar, I'm working as a tech lead with an overall of 10 years of experience, but extensively working in blockchain past 6 years and in decentralized identity from past 5 years. So, I think we are good to start the session, right? So I'll just we'll just explore the decentralized identity and digital credentials today. So like blockchain has a lot of use cases, plethora of industries where it is adopted, and there are different kind of blockchains as well. And there is a term decentralization which is attached to it, right? So it's a different spectrum altogether, which we call it as decentralized identity. So we'll just have a look at it today. So what allows us to talk about decentralized identity? So I'll just give a brief introduction about Ironworks. So like why I'm speaking about decentralized identity and digital credentials today, right? So at Ironworks, our vision is to enhance the digital trust and make digital transformation, like privacy enhancing digital transformation, so that everybody, like every entity, has a sovereign, secure, sustainable, and verifiable digital identity and data. Like data is a fuel, new fuel, we say, right? So to have a secure, sustainable, and verifiable data, we work towards it. And we are based out of India. We are made in India. We are a global player. So we are into blockchain from 10 plus years and 6 years specifically in SSI, which is self-sovereign identity. We'll have a look at it, what is self-sovereign identity, how it works and everything. And we have catered to a lot of clients. We are working in different geographies. And we have created decentralized identity solution for multiple states. We are working with Bhutan for to help them to create their national identity. And it's since last 3 years. We were in finalist in like one of the challenge in India, Digiyatra. And then we have a product called Credible. We made it open source. It is DPG. So we'll have a look at that as well. So this made us a global player. We have catered to a lot of projects in the space, blockchain, and decentralized identity. So, just 1 minute. There is, yeah. And apart from working on SSI, we have a presence in a lot of forums, global forums, which is very specific to decentralized identity and blockchain forums. So we are contributing members to DIF, Trust over IP. We actively participate in internet identity workshops. We are founding members of LFDT, which is Linux Foundation Decentralized Trust. And we are contributing member to DICE, which is specific to Europe for decentralized identity. And we are member of Open Wallet Foundation as well. So we are contributing to the technology, and we are using the technology as well. So we are like members of all these core community, which is working towards decentralized identity. And as I said that we have multiple, we have global presence. So we have catered to multiple international customers, and we are working with multiple governments as well on different geographies. So we have catered to, like you can see all across here. And one of the prominent is like we are working with Bhutan, an entity in Bhutan, which is DHI, from past 3 years for their national digital identity project. And we have implemented like the same, we have piloted the same for one of the country, which is Papua New Guinea, for same SSI stack for national identities. So these are some of our, and there are so many other private sectors identity projects also that we have been working on. These are apart from blockchain projects. So they are specific to decentralized identity that we are working on, that we have taken. So these are our expertise. Like with blockchain, it comes multiple things, right? You would need frameworks to develop applications. You need mobile apps as well. There are databases, deployments, and we work on multiple ledgers, protocols. So public, permissionless blockchains. So these are all the ledgers that we work upon. So this is why, I mean, these are all our credentials which allow us to talk about decentralized identity and digital identities. So that was about why I'm talking about like identity. So let's talk about this topic one. So identity is nothing but who am I, right? My representation, or to which I am related to, with where I belong to, what I belong to, who am I. So my expertise, if I'm a student, I have my different identity at college, for my family, for my professional career. So these are my representations, which we call it as identity. And we carry two type of identities mostly, right? So one is like we carry two type of identities. One is the cards that I have in my wallet, physical wallet. And then there is something which I have in one of the very prominent asset, right? That is mobile. So I have my identity in my phone as well. So there are two type of identities. Like one is the paper-based identity that we call, and another is digital identity. So I have different electronic representations of myself. So that is digital identity. So like today we will be talking about, like we will be seeing digital identity. So there are different type of digital identities that I see. So like first off, these are called models of digital identity. So the one is centralized identity, where an organization is issuing you a credential and you're using that credential for the access, right? So these are centralized identity. And these are like, they can be anything. Like I can have my identity card, which is specific to an organization or specific to a institution. And they are not, I am not using it anywhere, or they are just centralized, they are stored in a centralized manner. So this is called centralized identity, which is used like prominently, which was used. And we have seen a lot of mishaps with centralized identity, like theft, identity theft, and data breaches as well. So this is the first model that we generally use, is centralized. Then there is something else which is called borrowed identity or federated identity, we call it as. So there is someone else which is giving an identity to me, and I'm linking it to some organization. So it is called third party. So I have my account, like IDP. So IDP is identity provider, right? So I have borrowed my identity from one organization and I'm using it to log in it as on a different organization. That we call it as federated identity. So in this scenario, someone whom I'm asking for my identity become the data owner, or it holds all my data, right? And the other party, I'm logging in as XYZ, right? I'm going to GitHub and I'm logging in as XYZ. So that is become the that holds the user's data, that holds my data, right? And I'm just using the identity which that big tech organization has given me. So that is called federated identity model. Like we call it as more like trust me, I have your data, you can use it. So it's like that is federated identity. And the next one, like, but in both these identity models, what we saw is someone else is holding my data, right? I'm just, though it is my information, it is not me who has data. So in this world where they say, trust me, it's not you, it's me, but it's actually me who has my data is with someone else. So they are the single point of attack, single point of failure, single like identity thefts are happening. Anyone can track you, trace you, and then they can predict what will be going to be your next step, like where you may want to go shopping, or what is your likings. Everything we can trace, right? So user profiling can be done. So because the control of the data is not with user, it is with either issuer or verifier also has the data, right? So, and if I want to get my data somewhere, if my data is all over internet, my data is spreading all over internet, I don't know about it. I'm just getting calls or getting something from offers from somewhere, right? So that is what identity is spread across, because I am not in control of my ID. So there are so many other things, like the list is very long, and how my data is getting used, right? And I think it will be a ever-growing problem. So there's, but apart from all these things, like if there is a very like picture here that says that it's a very famous image, which says that no one on internet knows that you are a dog, even if you are in front of your laptop, or if you are over internet, if you type the name John, everyone will recognize you as John, right? So no one knows that who am I. And because I don't have any authority as well, right? So, but imagine a world where you can, like, if I want to share my data with someone, I can give the consent. Like, I just want to share my data with one organization. I don't want that organization to share it with someone else, right? So in that way, I can spread my data leakage. Or assume a world where you have the same level of trust and confidence, like with the scanning of your passport and not the in-person. Like the in-person is not needed. You will just prove your identity over online. So these are the things that are ease of access, right? Then it's just not about individuals. Like we talk about individual identities, right? But it implies to organizations as well, to entities as well, right? So provable identity for organizations, whether this organization is valid or not, what is real-time verification we say. So if we can do that, like it's a ideal futuristic world, right? But that ideal futuristic world is possible with one of the identity model that we call it as self-sovereign identity. So it is not just about identity for individual, but it is for identity for individual, entity, organization, and anything which is there, which exists. Because everything is tagged with an ID, right? So to have a provable identity over internet or a trusted identity over internet, there is a new identity model that comes in, which is called self-sovereign identity, a decentralized identity. So self-sovereign identity is, we saw in the previous models that I am not the owner of my ID, right? I have borrowed it from somewhere and it's keep on getting shared. It is not securely shared and all these things. So with self-sovereign identity, I can be an individual, can be an owner of the identity, and an individual can choose who I want to share, what data to share, how much data to share. So all these things where the user is in control of its identity is the basic principle of self-sovereign identity. And I can share over a secure data sharing application, like secure messaging. So, and to store the metadata, like what is getting shared, I'll also to have the metadata, not the actual credential, we use a distributed ledger, which can be a blockchain or distributed ledger. Verifiable data registry is the term that is usually used in the world of self-sovereign identity. And blockchain can be used there to store the metadata. So that's what self-sovereign identity is. So we saw in previous identity models where the control of the data was with issuer or verifier, though the data is of an individual or an organization or an entity. But in self-sovereign identity, the picture changes. So now the control is with user, and issuer and verifier are just entities who are asking for data, and they cannot reuse the data. Like even if I shared my data with someone, they cannot share it to someone else and prove it that it is they are the user or they have the authority to share it. So that's how SSI gives a control to the user back for their data. So that's how the locus of control changes in SSI. And from issuer verifier, it shifts to user. And the necessary details of legitimate, whether it is a legitimate issuer, whether it is a legitimate verifier, got registered on blockchain or any other DLT. So that's what self-sovereign identity is. So now this is a, like, as I said, ideal and futuristic world where we can imagine all these things happening, right? But this technology has evolved, and there are a lot of building blocks like for this self-sovereign identity tech stack. So these are some of these are the building blocks like DID, decentralized identifier, verifiable credential. There is a trust angle. There's a digital wallet, because I need, if this tech stack has something else to offer, then I need special kind of softwares as well to run, right? And digital agents and trust registry. So we'll just have a look at all these building blocks individually as well. And so let's start with credentials only, because we are talking about credentials, right? So let's start with verifiable credentials. So verifiable credentials are like the usual credentials that we have. They are not fit for this digital world, right? And I need something which is, if I'm talking about sharing my credential online and verifying it, then it should be verifiable, right? It should be secure enough. So verifiable credentials are cryptographically secure. They are signed, and then with that cryptography you can verify those signatures as well just in time. So they are digitally verifiable. They are cryptographically secure, and they contains all the data that a verifier needs. So what a verifier needs. So whenever I want to share my credential, right? If I want an organization to verify my degree, so they need who has issued it. What is my name? What is my personals? And what are my marks, credits, or all these things. So all these information about issuer signature, data, validity, all these things are there in that verifiable credential. And verifier can easily verify that credential over internet, which is being shared. So, and it has it also has a information about the holder. So it's not like if I can save someone else's data and I can share it on behalf of the person, right? So it has an information about the individual as well. So it contains the data, it has a valid issuer signature, it has a expired or revocation, if it is still valid or not, that information, and it provides a cryptographic proof, which can be used to validate all these information. So verifiable credentials are based on this cryptography, like strong cryptography of the data. So this is how there are different formats of verifiable credentials. So this is one JSON LD verifiable credential. So it has proof of what type of signature. We can use different type of signature algorithms here. And there can be multiple type of signature algorithms, as I said. So proof can be generated in those algorithms. So that's how it's just a simple format of how a VC looks like. The second building block was decentralized identifier. So if someone wants to send me a letter, or an email, they should know my email address, right? Or they should know my postal address. Similarly, if an issuer, if an institute wants to issue me a degree certificate, they should know my identifier. And if we are talking about cryptographically proven credentials, then those identifiers should also be created in a similar way, right? So here comes decentralized identifier. So they are different kind of identifiers, not like our email ID or maybe our identity number, login IDs, but they are very similar to it. They are created in a different way so that you can prove yourself. So this is an example of how a decentralized identifier looks like. And it is created by public-private key pair. So when we know that whenever we want to sign something, we want a public-private key pair. Like blockchain is based on a symmetric key, right? So public-private key pair we create, and then an address is created. Similarly, a decentralized identifier is created by a combination of public-private key pair. So every DID is attached to a public key, which can be used to verify the signature, and a private key, which is used to sign the payload. Okay, so this is called decentralized identifier. And what is so special about this identifier? So first, it is like, as I said, it is cryptographically verifiable because it has a key pair attached. It is generated by a key pair, right? And we are talking about decentralized identity, right? So it is decentralized. So because you can create it, you can share it, and it resides where it is created. So we can have the identity created in any of the wallet or any of the anywhere, any of the storage where it supports, and we can share it as well. And it is resolvable, of course, to the public keys. You can resolve who has the authority. So these are the specifications which are in W3C. You can go and check W3C standards for DIDs, VCs, and all these specifications, how to create it, what are the different types of DIDs. You can get it over there. And they're permanent because once you create a public-private key pair, it remains the same, right? So it never changes, it is the same. So that's why decentralized identifier is a special kind of identity, which I can have in this decentralized world, and which will be used to identify myself. So the next building block was entities. Like we call it as trust triangle in SSI world. And because it needs an ecosystem, right? It needs different entities. So we are talking about credentials. So someone is holding the credential, someone is issuing the credential, and someone is verifying the credential, right? So these are the entities which are there in a self-sovereign identity model. So there is an issuer which issues a credential to the holder, and the verifiable data registry or ledger is used to write the metadata. The metadata is not about the credential which is being issued, but it is about the identity of the issuer. Like what identity? It's the DID, right? Because we saw that DID is the identifier. So verifiable credential has the DID of issuer and something and few things related to the revocation. And this is how a credential is issued. And then whenever a verifier comes that I want your degree, so please present your degree so that I can see that you are a student you are actually a student who has passed out, right? So verifier asks for presentation. Holder creates the cryptographic proof of that credential and share the presentation proof that with verifier. So here there are different type of proofs that are created. Like you can create zero knowledge proofs, and you can have selective disclosure. So let's say my identity has a lot of things in it, a lot of attributes, right? But if I want to prove that I'm above 18, so if it is a question that I'm above 18, the answer should be yes and no, right? So the data should not be revealed. Only the information about if whether I am or not should be provided to the verifier. So that we call it as zero knowledge proof. And verifier should be able to verify that. So that is the beauty of the cryptographic proof that is generated by holder. That verifier can verify that whether the proof is correct. He reads the DID from the verifiable data registry and he verifies the signature. And we can have partial disclosure as well. So if my degree contains like X number of or 7 attributes, but if verifier only is interested in my aggregate and my name, then I can only share those 2 attributes. So that is called partial disclosure. So that ability is also there. So you can just verify, you can just share whatever data is needed by the verifier and not more than that. And verifier can very well verify it using the data that is there on the verifiable data registry and prove that is shared by the holder. So that's how like a trust triangle works. And this is one of the like core building blocks. Now there are digital wallets. So as I said, we have our physical wallets to store our cards, right? We have our normal phone storage to store PDFs or our credentials in PDF format or file format or image format, right? But these are different kind of credentials. So we need special wallets for storing them. Who can read the verifiable credential, who can store the verifiable credentials, and who can generate proof out of these verifiable credentials, which has capability to generate a zero knowledge proof, to generate a selective disclosure proof. So those are called digital wallets. So they store your digital credentials, which comes with your keys and everything. And because it is in your control, you have a pin for that, which you have tied it to. So it is protected from theft. It is not going anywhere else. It is handy because it is in your phone. And there are like these wallets are created on open standards, which are W3C standards, Aperture Aries RFCs. There are standards for OpenID for VC and VP. So on these standards, these wallets are created. and they work with digital agents. And there are different type of wallets. So there is cloud wallet, edge agent, edge wallet. Edge wallet is nothing but wallet on my phone, and cloud wallet is nothing but if optionally someone wants opt to not have phone to have store in cloud, they can. So these are digital wallets which reads this special credentials. Now there is a term called digital agent, right? So the next building block is digital agent. So this wallet is something which reads, operates, generate proof, but to which software module it operates with, right? Who will read the wallet? So that is where agents come into picture. So it's a module which operates the wallet on behalf of a owner. So there is an agent running, it is on my mobile or on cloud, and it operates my wallet. So agent also uses standards, protocols, W3C standards, and all the Hyperledger Aries protocols. All these protocols are also like pretty standard protocol, and they're secure. They digitally they help you to create a peer-to-peer connection. So in the previous slides, we saw that self-sovereign identity helps us to make a peer-to-peer connection, right? Share it securely with an individual identity. So that this agent helps us to make those connections and exchange the credentials over internet securely. So these were the building blocks. Now, this technology is like industry agnostic, and wherever there are paper-based credentials, wherever there are credentials, we can have verifiable credential for them. Because when we have credential, we always have credential to prove something, right? I saw that I have facades, which I call it multiple identities. So why I need those? Because I want to prove myself. So wherever there is paper-based credentials or any form of digital credentials, that these verifiable credentials can be used to replace those paper-based credentials to have easy provenance. So we can use it as in healthcare for records, financial institutions, education for degrees. We can have in travel, transport, e-commerce, government, telecom. Everywhere where there is credential, we can use digital identity, decentralized identity. And it is not just for individual, it is for entity, people, thing, and devices. Because everyone in this, every entity in the world has identity tagged to it. So there are a lot of use cases, and in our country also we have a lot of domestic use cases. So Digiyatra is one of the widely used domestic travel application, which made this check-in process, security process very easy and it uses the same tech stack. It uses the same tech stack for secure and safe travel credentials. Then we had our vaccination certificates, right? And there was a QR code on our vaccination certificate. So our CoWIN platform, which was used for vaccination certificate, is also using the same data model. So we saw a data model of the credential, right? It was in a specific format, which is the W3C format. So CoWIN also uses the same data model for this vaccination certificates. And it was about the country. Then there are so many case studies across industries, so many implementations across the globe which are happening. So for travel, Digiyatra and IATA, International Aviation which manages international aviation. So IATA also has a One ID. And then there are so many use cases where passwordless authentication is happening. So I'm doing passwordless authentication, but I am using identity which is given by someone else, right? So instead of that, if the identity which is there with me can be used as passwordless login, so it is even better, right? So that passwordless authentication is also getting used. Then e-commerce also has a lot of implementations. Open Bazaar, Barclay cards, these are few of the projects. Then education, so degree certificates, badges, micro credentials. So to make them real time verifiable, like we know there are so many cases of fake degrees or incorrect degrees, right? All that can be avoided, can be eliminated with this. So education sector is also using it. European Union Digital Wallet Consortium, where all the European Union countries are coming together to create a framework for this digital identity adoption. Then European Blockchain and Services Infrastructure. British Columbia is extensively using this. GaiaX is one of the, which I mentioned earlier as well. So GaiaX also for one of the project. Then there are so many supply chain, financial institutions. So passwordless login comes with eKYC as well. I go every time in bank and I have to submit my details, right? Why not just create one credential and give it to them again and again? So that is eKYC. There are so many things going on with IoT context as well. So SSI can be very well integrated with devices to give devices an identity. So these are few of the industries. There is a variety of industries, right? Wide range of industries. Then there are some other case studies and implementations, I would say. One of them is National Identity of Bhutan, which is first of its kind, like first nation to adopt self-sovereign identity for their national IDs. And now they are using that for KYC, education, employment record, address credentials, birth certificate, marriage certificate, and many, many more things. So they are using it for a lot of their government services. And Papua New Guinea, who is also giving verifiable credentials across to access their government service portal. So, and one of the implementation of verifiable credential is with with NIPER, which is our National Institute uh, in Medicine. So Educrates is one of the product which is built by Ironworks. So that is used to issue verifiable credentials to postgraduates. So like few of them we have worked on, and yes, at Ironworks we take prides in having worked them on these solutions. So these are some case studies and some implementations across the globe. There are so many work going on for this national identity, because we know, yeah, this is nationwide implementation. They have, like, His Majesty took a lot of efforts to get the NDI adopted. And there was one more thing, like World Memory Championship happened in India, and we also issued these verifiable credential to the World Memory Championship winners. So these are the credentials that looks like that reside with you. You can share them with everyone, and they can prove it. So these are few of the use cases where this self-sovereign identity is used. And with the law that is coming for data privacy and protection, like DPDP, GDPR, HIPAA, and there are so many data laws which are coming, right? So our data is sensitive and it is important. So to protect that data, this technology is really playing a good role, and it is needed for my data privacy. So, okay, this is about the tech stack, digital credentials, decentralized identity. But how to get started? Okay, like what if I want to use like this technology has a lot to offer. But what if I want to implement something? What if I want to use it? Or what if I want to leverage it to create some use case, right? Or I want to contribute to it. How can we start? So we at Ironworks have built a credential management platform that we call it as Credible. So it has the whole life cycle of a verifiable credential. So it has credential issuance, verification, revocation. So this platform can be used by any government, enterprise, business, academia, anyone to issue credential to the individual. You can go log in and you can start creating, issuing the credentials. But what about holders? So my identity, but where I will store. So there is a personal credential wallet app. We call it as Adeya. It is used by individuals for storing, viewing there, and sharing the credentials. So you can share your credentials, you can view your credential here in the Adeya application. So it can be used by corporates, individuals, or things or devices. And Credible is a DPG, like digital public good. It is one of its kind, DPG, where it's a recognized digital public good for self-sovereign identity. So it's a DPG, and it is planned to move under LFTT, which is Linux Foundation Decentralized Trust. So soon it will go under Linux Foundation Decentralized Trust, and it is already open source. So Credible is open source DPG. And there are some key features of Credible. And if you want to contribute, I mean, these are the community, these are the softwares you can say, or these are the frameworks or applications which are used for any self-sovereign identity application. So Credible uses open standard, it is open source, it uses W3C standard for DID and VC, and it is under Apache 2 license open source. Since it is using all the protocols, it is privacy by design and by default, and there is always consent by the individual holder. So it has an agent, it has digital agent, it has digital wallet, it helps you to create DID. It helps you to have all that trust triangle, right, of issuer, verifier, and holder, to have that in place. It also has blockchain, so it supports like and it is used in production, and it is for scale, and it is used in across industries. So these are some of the standards that it follows. It uses Hyperledger Aries, W3C standard, frameworks in Open Wallet Foundation, and it is a DPG. And it uses multiple blockchains. So Indy and Polygon are two of the blockchains. So we want to write that metadata on the ledger, right? So it uses Polygon and Hyperledger Indy for that. And it uses multiple networks. So Polygon also has different type of networks, right? And Hyperledger Indy also has networks. So it supports different networks. When we were looking at DIDs, that time I said that there are multiple type of DIDs, right? So there are different type of DID methods. So Credible supports wide range of DID methods, which are widely used. And the verifiable credential payload that we saw, right? There are different type of VC formats. So the mostly used are Anoncred's W3C, which is JSON LD. So Credible supports both of them. Then it has a different governance, because when it comes to internet, you need to have some governance, right? So who is the trusted issuer? Who is the trusted verifier? Who is verifying me? Is that legitimate or not? So that their governance comes into picture, which we call it as trust registry. So that is also a part of Credible platform. And it also has FIDO passkeys. So FIDO is also one of the identity, like a different kind of how identity can be used, can be stored. So it uses FIDO passkeys as well, which is used for biometric based passwordless authentication. So it uses, like Credible uses Ekapi, Credo, Polygon, Indy, passkeys, and a lot of other standards too. So this is about Credible. There are so many so many standards. If you want to go and if you want to look at these frameworks, if you want to contribute or see how these frameworks are, or what are these agents. So these are the agents that are used, Akapi and Credo.ts. So you can go to that, you can go to the repository of Credible as well, and you can check how this ecosystem is built. You can start, since it is open source, you can get started with it, or you can use, if you want to try out, you can go to the SaaS platform of credible.id, you can use that as well. And you can have a take, if you want to contribute, you can just go to any of these frameworks or any of this GitHub repositories of these agents, wallets, and you can have a look at them as well. So yeah, so the team which is working for Credible for serving the clients. So we have a wide variety of teams. Team which is working on it, and you can get in touch with us, or this team work on all variety of frameworks. So as I said, that we contribute to the open source and we consume open source as well. So this is the team where we have SSI stack, blockchain experience, and developers, full stack, everyone. So we can, you can go ahead, have a look at Credible, have a look at decentralized identity, how it works, and what it caters to, and what are the different areas it helps you in. So you can scan this QR code and just join the Credible community too. And I think if you have any question, we can take questions.
Yeah, thank you, Ankita, for the presentation. So before we take up the questions, a couple of announcements to the audience here. So we'll be glad to issue a blockchain-powered certificate to all of you. You have just need to fill a feedback form, which will be shared to you soon enough, so that you can, with your comments, we'll be able to give you a blockchain-powered certificate. And now we move on to the Q&A session. So your participants can ask the questions to the speaker. And if you have difficulty in unmuting yourself, you can paste your questions in the chat also.
The blockchain has a lot of implementation, and like it's, as I said, it is a broad spectrum in where blockchain can be used. So, and as a technology, it has a lot to offer, and in self-sovereign identity as well. So we can use it. It uses the essence of blockchain. Is it possible to amalgamate with AI? Yeah, you can. We can build use cases with AI as well. So since self-sovereign identity is more focused on like where the data storage, data access, but wherever the data is stored, we can very well bring the AI over there. Like it is the use of access, right? So if my mobile app has something, my data is there in the mobile app, it can give me like alerts for whether if someone is sharing up, asking me something, we can have AI on that to check whether it is a legitimate verifier, whether it is asking details very frequently to me or not. All these things can be done. Is there any material or tutorial for students and learners from where they can do hands-on tutorial, or any platform especially for SSI identity management? Yeah, so platform, if I talk about, I told Credible. Credible is one of the platform where you can go and just play around, and you'll be able to understand how SSI works. And then there are so many frameworks. So I'll just post few of them here as well, so that you will you will understand. So you can go to GitHub repository of Linux Decentralized Trust, LFDT, and you can get the materials over there. I'll just paste few of the links here as well. So I'm not able to see the chat. Without ZKP, can we implement the DID? Yeah, DID is an identifier. ZKP comes after DID. So I need a address, right? Then only someone will send me the data. So zero knowledge proof is on the data. First, I need identifier. DID is the identifier and ZKP is afterwards, the ETL on data, you can say. So yes, without ZKP, we can implement the DID. How the DID solves real-world problems in food and food services. So food services, if you will see the supply chain of food, right? So we can have the identifier for all entities, and we can use that with the IoT devices to check about the material as well, and then we can track the food or the services over there. So DID is basically that DID identifies the particular entity which you are transporting from one to other, or it helps you to narrow down to the entity. So this is one of the use cases in food and food industry. There can be a lot of those where we can have the storage of the food. How machine learning can be used in this technology, if it can be used. Like machine learning is also a very like AI ML is also a lot of I think it is related to AI question only. So you can have you can go and try out how the data is being stored, what things we can do, how to easily access or provide access to the user easily. There we can use AI ML. Was there any difficulty faced while implementing identity management in different countries? Yeah, of course, every country or every country or every use case has their own way to manage identity, right? And adoption is one of the challenge. But now with the frameworks that are coming in, with the regulations which are coming in, it is getting easy to get this technology adopted. And of course, scaling was the problem that because this technology is very niche, right? You have to test it thoroughly. Then you have to plan it for the scaling, for the implementation. But those can be done with the government organizations. What happens if an edge agent or digital wallet is lost or corrupted? So we can take backup as well. So there are options to where you can take backup of the data. So you can take the backup locally of your wallet, and it can only be restored with the we know that when we create a digital wallet, right? For example, MetaMask. So we get a seed. We have to set a password, right? So similarly, you have to when you will export the wallet, you will get seed or you will get password, and when you want to you can recover that wallet in the same kind of digital wallet or digital agent, and that will help you to recover the identity. And your wallet will have your data and credentials, everything, so it will be safe. But you have to take regular backup for that. So can we use for preserve the privacy in healthcare? Yeah, healthcare also. We have patient records, right? So we can have verifiable patient records so that my records are scattered. It is when I go for claim, I do a photocopy of that record, and I give it to someone else. They copy it, they give it to someone else. So it is like replicating like my data, right? So I can have verifiable credential of my records, and I can have a history of records as well. So, and that data will be with me. I choose to share my diagnostic report to one doctor, and I choose not to share the diagnostic report with another doctor, and they cannot be stolen. And
Hello, ma'am. Ma'am, how does the self-sovereign identity help in digital asset ownership, ma'am?
sorry, it is echoing a lot, so I cannot understand.
Okay, ma'am. Can you hear me, ma'am?
Yeah, I can hear you now.
Okay, ma'am. How does the self-sovereign identity help in digital asset ownership, ma'am?
So asset ownership, so you are giving a identity tag to the asset. Is echoing a lot.
Yeah, Varsha, could you mute now so that our speaker can answer?
Yeah. So asset ownership, we have an identity for, as I said, that it can be for an entity, individual, thing, or device, right? So we can did to the asset as well as to the owner. And when the owner asset is transferred to the owner, that did goes in the credential with the owner as well of the asset. So that identifier of the asset, right? That the did of the asset can also be attached to the did of the owner. And we have the identity of the owner as well, that the did belongs to which wallet, which owner. So that details are also there. So asset can be managed with did and this credential model. And a person can have multiple dids. Yes, they can have. Which blockchain is used? Blockchain, as I said, there are different type of blockchains that you can use with self-sovereign identity. SSI also goes ledgerless. So VDR is verifiable data registry. So we don't have to use blockchain. It is not mandatory to use blockchain, but we can use blockchain for this credential management, because credential doesn't go to blockchain, metadata goes. So credible uses Hyperledger Indy and Polygon, and also ledgerless. What type of consensus algorithm? Consensus algorithm depends on what blockchain you use. So if you use Hyperledger Indy, it is PBFT, RBFT. If you use Polygon, it is something else. If you use Fabric, it is something else, right? So it depends on what ledger you use. And how does decentralized identity integrate with traditional system without disrupting existing workflows? So not every time, like it's a way you manage identity, right? So earlier we have username password as login. Then we gave an option to log in with Google, or log in with Facebook, or log in with Instagram, right? Or log in with Twitter. So these are the options that we have given. Now we can give an option to go passwordless with verifiable credential. So these are the options that we can give in the traditional system. And whenever the traditional system wants to discontinue the centralized identity model, they can do it if the adoption has happened for other models too. So that way they can go parallel. And they can just like NIPER also issued verifiable credential, and they also give physical degrees. But students have verifiable credentials so that they can prove themselves online. It's a benefit to the student, right? So in that way, traditional system can go hand in hand. I have heard that Hyperledger Indy is shutting down since Indy has been foundational ledger for Central. How will the impact? So so if Indy is like if there are applications which are using Indy, they can be migrated to other ledgers as well. So we did a migration, like at Ironworks, we also did migration for one of our clients where they were using Indy, but now they are using Polygon. So those migrations needs to be done. And if you want to use blockchain, you can migrate the metadata from one blockchain to another blockchain. that that migration needs to be done if we have to switch the blockchains. And yeah, like those using Aries and DITCOM protocol. So DITCOM protocol is also not, we can use it with blockchain or without blockchain, as I said. But if you want to switch blockchain, we can do that. And can we preserve the privacy using Hyperledger Fabric? Fabric can be used as a VDR, but credentials are verifiable credentials. So where we are using to write the metadata, right? We can we can use Fabric over there, but the data model we have to create a verifiable credential only. So we have to use W3C verifiable credential model to issue VC, verify VC, cryptographically did method already, all those are there, but Fabric can be used as a DLT.
Yeah, Asin has asked one question, raised hand. So Asin, if you're there, you can ask the question. Okay, any more questions from the audience?
Hello, ma'am.
Yes,
I
Neha.
have a hello.
Yeah, go ahead, please.
Ma'am, what are the biggest challenges organization face when implementing SSI solutions?
So SSI is a very new technology, like niche, right? So first, as I said, adoption was a challenge. Now it is getting resolved as laws are coming into picture, because we don't pay attention to our identity. It is okay. I give my identity to anyone very easily, right? So adoption is one of the challenge. Then there are the softwares are also the agents, the digital wallet, the digital agents. They are also scaling and they are also getting upgraded. So there are a lot of contributions happening. But one of the biggest was adoption. And of course, we have to build the capacity also for uh, SSI developers. So you creating these agents, wallets, that is also one of the challenge. But with the laws, it is getting easy now.
Yeah, Sujit has asked, raised some question. You can ask the question here, Sujit.
Hello, ma'am. I have a question. How to meet the primary cost issues when implementing DID?
No, sorry, I didn't turn. Could you please repeat?
How to meet the primary cost issues when implementing DID?
Cost issue, is it?
Yeah.
In creating DID, is it?
Yeah.
So DID creation, you need an agent, you need a wallet, you need an agent to create it. And if you want to write it to a blockchain, it is optional. If you want, if I'm using that DID to sign something and I want someone to verify, I'll write that DID to Ledger. Then there is cost. If I'll not write it to Ledger, there is no cost. I can create DID. There are softwares, there are libraries available. You just have to invest some time and find out. So we can create DID.
Yes,
But cost when we have to write to Ledger. Yeah, sorry.
Yeah, Anjana was asking something.
Ma'am, how does decentralized identity ensure user privacy in financial institutions?
Sorry, there is a lot echo.
How does decentralized identity ensure user privacy in financial institutions?
Financial institutions also have KYCs and a lot of things, right? You can reuse the data that you have already provided. So you don't have to go and rework and do all these things. There is no or less chances of fraud as well. Someone is impostering me on my data, or I'm giving my ID to someone else is going with my ID with all. So that can be reduced eKYC is one of the biggest use case there. Can you explain a real world use case? Yeah, so there are use cases of zero knowledge proofs as well. As I said, that if you want to prove that this is a very common question, are you above 18 or are you above 21? Are you valid for a driving, right? So these are the questions. So as I said, in Bhutan, they are also they have also implemented it for road transportation, where they are just asking these questions and getting the appropriate ZKB based answers, like not the whole data, but whatever is needed. So a driver can ask for do you have valid driver's license? You can say yes or no. You don't have to share your driver's license, the whole details. Or are you above 18? You can just, it gives you a calculation and gives you answer yes or no from based on date of birth. So these are the real world use cases that are being used. If an active deed holder is deceased, what will happen to that deed? That deed remains as is. If it is on ledger, it will remain on ledger. If it is not on ledger, it will remain in the wallet. If the wallet is there, active, it will remain.
So if there are no more questions, we shall wrap the session. Or
Over time as well.
should we give another round for a set of questions from anyone ahead?
If you have any other question, you can ask, or you can get in touch with us as well. You can post your questions on community as well. So credible community, so you can post your questions. We can answer there as well.
Okay, so I think we do not have any more questions. So thank you, Ankita. Thank you for the amazing presentation, and it was such an insightful discussion. And thank you so much for the informative session. And we look forward for further collaborations with you and your expertise in similar events to come. And all the best for all your ventures.
Yeah, thank you so much for giving the opportunity.
And to the audience, thank you for the overwhelming participation. Make sure to subscribe to our YouTube channel for future notifications and similar updates. Yeah, thank you. Bye.
Thank you all. Bye-bye.